All right, so let's review what you should know for Chapter 11. Remember, I said there were 3 key skills, and now we're coming to pretty much the end of the second skill. But the first one was you needed to know area approximations, which your trapezium rule, your left-hand rule, your right-hand rule, that was the very first exercise of Chapter 11. Then your bulk of your learning actually is then pretty much skill number 2. And I say bulk mainly for the students who don't do specialists, because specialists would have practiced integration quite a bit. The students who haven't done integration and only did a bit from last year, you guys have a lot to learn. You are essentially working out all the antiderivatives of all the different functions. So you got e to the x, you got sine of x, you got cos of x, you got the different types of power functions. So you got 1 on ax plus b, but you could also have 1 on ax plus b to the power of n. So whatever that number is. So you need to know how to antiderive all of those. Log as well, log base e of x. And then the final part, which is what we're doing today, is we're finishing off definite integrals. So all of the one that I just said up above, this is called indefinite. Usually has a plus c because we get a function or an equation. Definite integrals actually work out the area. So they have to give you an interval. So between a and b. So a and b. And the theory I gave to you guys yesterday was capital F of B minus capital F of A. So that was definite integrals yesterday. Now I'm finishing it off. So we're still using definite integrals, but we're now looking at areas under a curve, but between 2 curves. Okay, so it's not just under a curve, but it's between 2 different graphs. So here are the notes for today's lesson, and then after that, that's pretty much the bulk of number 2. Your final bit, number 3, is the leftover kinematic stuff and average value. Okay? So here we go, which is applications, really. All right, let's have a look at today's lesson. I'm going to go through a couple of examples just to give you a vibe. But what is the rule for exercise 11I? Area between curves is given by this formula here. So it says between A and B, if you found the area between A and B, so here's the interval, A and B, and you want to know the area between f and g of x, then the formula says it's f of x take away g of x, f of x being the upper graph, and then g of x being the lower graph. So you can see here, f of x is the larger y value, and then blue graph, which is g, is the lower y value. And the logic to it kind of makes sense, because if I just asked you to do antiderivative a to b of f of x dx, you would have got this area, right? And then if I asked you to do the antiderivative in blue of a to b as well, but g of x this time, then you would have got this blue region. So then if I asked you to take the red region minus the blue region, well, of course you're going to get the leftover. Okay, so that makes sense why that rule works, but it means the order matters. Which one is your upper graph and which one's your lower graph, and that's the only thing you have to determine. So what's the challenge then? The challenge is when you get graphs like this. So in this is a typical sine, cosine graphs that usually occur in this kind of property. See, it alternates between which one's the upper graph. So between A and C1, so if I had to work out the area between them, I would take F, take away G, which is this one. But then if you look at the between C1 to C2, G is now on the upper graph, and then F is the lower graph. So you would have to then split it up and say, it's C1 to C2, it's now G, take away F, dx, and so on. So it alternates between F to G and then G, take away F. It means you have to split up the intervals when you see the graphs change on the upper graph minus the lower graph. Okay? So that's the only thing you have to be worried about? Do you have to worry? And another concern that students generally have as well, that they get confused between. When you're working area between curves, it doesn't matter if part of it is below the x-axis. Okay, so the area between them, so if I color them in now, this area, students get confused by thinking they need to split up the interval for the top half and then the bottom half. You don't. Okay, and the reason for it, if you think about it logically, is that had I even did a translation of these two graphs and moved the axes down, calculation, the area doesn't change. So just because it's below doesn't mean that you have to change, the answer doesn't change. So it's still top graph between these two intervals, top graph minus lower graph. So it'll still be F take away G. Okay, so don't worry if the axes look as if there's parts below and then parts above. If it's areas between curves, it actually doesn't matter. Okay, so you just calculate between the two intersections to get your two intervals. Work out interval A to B. Take the top graph minus the bottom graph. You get the area between two curves. Okay. All right, let's do an example just to get you copying notes and practicing. So say the first example. Find the area of the region bounded by the parabola. So I've got an x squared graph. Here we go. And a straight line y equals 2x. This is 2x. So, problem is I don't have the point of intersection yet. So I don't know where, if it's curves, the area between two curves, I need to find these two intersections. To find the two intersections, we know that we got to let them both equal to each other. So that's what I've done over here. X squared equals to 2x. Now let's see if we can solve this bit. Here we go. What's the next step? If I want to solve for the points of intersection, which are these two, I need to first find where the x coordinates are. So x squared equals 2x. What is the next step you're going to take in order to solve for x squared equals to 2x? Let's go with Adonis. What would you do first? How would you solve this equation? Move the 2x across. Don't make the mistake of dividing x by 2, both sides by x, because we're assuming x can't be 0. So here we move x squared minus 2x is equal to 0. What's the next step from there? Arian, what would you do? I've got now x squared minus 2x. I want to solve for x. What are you going to do next? Good. Factorize it. So you got x times x minus 2. So using null factor law, what would x equal to? Let's go with Una. What does this give me now? So we factorize the expression. X will equal to. Good. So x equals to 0 or x equals to 2. What this means is on the x-axis, I now know the 2 points of intersection. X is at 0 or x is at 2. So now we're going to use our understanding of finding areas between two curves. The top curve at the moment is 2x and the bottom curve is x squared. So I'm going to say antiderivative, which means find the area between 0 and 2. So 0 being the smaller number, 2 being the larger number. And we got to subtract the top minus the bottom. So this would be 2x, take away the bottom equation, x squared dx. And that's what our today's lesson is. Okay, so our lesson is upper graph minus lower graph. And I've got 2x minus x squared. Now, this is now applying what you've learnt so far in the term, or the last week or so, on definite and indefinite integrals. Let's go with the next one. Let's see, Alicia. We're going to antiderive. What's the antiderivative of 2x? What are you going to get? Beautiful. 2x squared over 2, because we add the power by 1 and then divide the same thing for the denominator. Then you try now, Krish. Next slide. What's the antiderivative of x squared? Good. There we go. Remember, you don't need a plus c when you're doing definite integrals. So we don't need to put the plus c. And now we know it's between 0 and 2. Next step. Definite integrals is you sub in 2 and then minus you sub in 0. So I'm going to sub in 2. So you get 2. Actually, I should just cancel these 2 out. The 2's cancel out. So you really get 2 squared minus 2 cubed on 3. So that's my f of b. Minus subbing 0. So 0 squared minus 0 cubed on 3. Which is convenient because clearly that's all 0 on this side here. So we can just cross that off. That means you just got to work out what 4 take away 8 on 3 is. And that should give us what? Times by 3, 12. 12 take away 8. 4/3. Squared units. So far straightforward. So that's the skill that you're taking out from 11I. If I said, do you know how to find areas between curves? That's pretty much what you got to do. What's the challenge? They can start moving things around. Sometimes they'll get you to change the integration in terms of y. Sometimes they'll get you to work with parameters rather than the actual values that I'm giving to you. So an example, I want you to try the one on the back of the page. That one was an exam question, which is nice, simple, works out nicely, but it does do exactly the same thing that I just did with you here, except the numbers feel a bit more intimidating. So here we go. Flip over the page. And this will be my last example. The others is some VCA questions that have solutions attached to, but I want you to solve this question. This was a 2011 exam, so more than a decade ago. Question 9 from exam 1, so no CAS calculators involved. I think it was a 3-marker. Shown in the diagram below. So here's the diagram, very similar to the one I just gave to you, except you can see it's got below the x-axis, gets a bit more confusing. They tell you the intersections is at 0 and m, whereas the other one was 0 to 2. Find the area of the shaded region. The area of the shaded region is 64. Find the value of A and the value of M. It's 4 marks, actually. Have a go with this one. I'm going to give you, 4 times 1.5. So give it 6 minutes. Shouldn't take 6 minutes. But just a bit of applying your knowledge. See if you can solve this one. Maybe I'll make it 5 minutes. Just so we can move on to the next exercise. Let's see. So hopefully you got the first bits. You got the intersection. Afterwards, it's really the same as what I did in the example. Let's see how many of you got the same answers. I got m equals 4 and a equals to 8. Pretty much the same as before. We know that g of x is the top graph minus the lower graph. You got linear minus cubic. Double negatives become a positive, so it simplifies to 2ax minus x cubed. You know it's between 0 and root 2a because you did it over here. And the area is meant to equal to 64. The simplifying bit, the crossing of the 2's was very similar to the other example. And to do things pretty straightforward. The only thing I can see that students screwing up is probably the substitution. So when you get up to this step, where you're substituting root 2a into x squared, remember squared and square root cancels out, so that ends up being 2a times a. And this one is to the power of 4, so it ends up being 2a squared. So it's just being able to do that algebraically with your certs and fractions. And if you did do that correctly, you should end up with 2a squared minus 4a squared on 4 equals 64. And it's your ability to solve through this equation. I times everything by 4. Simplified to the a squared. Square root of a squared. Square root of 64 gives you plus or minus 8. But remember in the conditions they said a is greater than 0. And because a is greater than 0, therefore a is 8. But if a is 8, m must be 4. Can we get a show of hands who got a equals 8 and m equals 4 for those who tried this question? Okay, good. And the others, if you hadn't attempted, the notes are going to be on OneNote for you to try. Okay, so again, this is relying on the fact that you know how to antiderive, you know how to do definite integrals, and then the applying bit is your algebra. Okay, just to see if you can work. But that's 11i. Okay, the essence of 11i I've taught. whether you're going to practice and learn it and master it, that's different. Okay, that's a different question. But there's a couple other questions for you to try. You've got the solutions as well for you to have a go. Otherwise, flip over to the last exercise for today. 11H. I'm going to teach you the final skill. So if you flip over this page, this is called integration by recognition. This is a methods type skill. Specialists may have learnt it. Can I get a show of hands? Do you guys learn this in Spec? Integration by recognition? No, probably not. Because you guys normally do it integration by parts, so you don't need to. But because in the methods exam, often they don't take into account that they don't write the questions for the Spec, they write it for the method students. And because of that, this is one of the techniques that is often used after they say derive and then hence. The hence bit means you have to use something you did in part A. So I would say you can't use integration by parts in that type of question. You can see it. Okay, so they'll usually say part A, derive, and then hence. That hence bit is where we're going to use the skill. It's a very straightforward skill, so I'm going to show you. And it's in 11H. There's only a few of the questions for you to try. Okay, so here we go. For this part of the question, part A, they want you to find the derivative of y equals x times cos of x. Let's do a bit of revision. How do you find the derivative of x cos x? What rule do you use? Can I please have Zach? What rule do we use to derive this function?
I just do it in my head and go the y part. I forgot what it's called. The product that we have, and go dy dx equals cos x.
Gotcha. Because you just know it. That's right. So the product rule is the name for it. VU dash plus UV dash. If you guys have forgotten it, essentially you notice that it's x times cos of x. So you got two functions. You got a linear, so you call one of them u, call the other one v, and then products of each other. So following the rule, vu dash. So like what Zach just said, v, which is currently cos of x, but he knew that derivative of x is just 1, so it's times 1, plus uv dash, u is currently x, and then derivative of cos of x. What is derivative of cos of x? Let's go with Aryan. Sign, good, but don't forget it's a negative sign. So u was equal to x, so u dash equals 1. V was equal to cos of x. Therefore, v dash is equal to negative sign of x. And that means that this is now negative x times sine of x. Now you found the derivative. Great. Which if I simplified this will give you now cos of x minus x times sine of x. Okay, so that's part A. Part A gets you to derive, and that was chapter 9 stuff. Okay? Part B is saying find an antiderivative. Notice it says and let's see if you remember what that and means again. What's the difference between the and an? Very good. So an antiderivative, you have to give, it could be any potential solution. Usually we say 0. So in summary, if you see the word and, you don't have to put a plus c because you're assuming c could be 0. If they say find the, there has to be a plus c, and you should solve for c at some point. So that's the difference between the two. But you're finding the antiderivative of x times sine of x. See the problem? You don't have that rule. We've taught you how to do antiderivatives for methods anyway. We've taught you how to find the antiderivative of x, power functions, sine by itself, log, exponential, and cos, but we haven't learnt how to do it when there's a product between two functions. So how do you do it? And why did they say hence? Reason is because part of your solution in part A has what you want. So you want this, x times sine of x. This has x times sine of x. So what we know in terms of properties is that if you found the antiderivative of the derivative, so here's your derivative, delta y delta x is, if you found the antiderivative of the derivative, that's the same thing as you saying finding the antiderivative of cos of x minus x sine of x dx. Okay, now antiderivative of the derivative is just opposites of one another. So if you think about it in a flow chart, remember you start off with y, you found the derivative and it gave you delta y delta x, but if you do antiderivative, you should get back y. So that means this equation, I already know it's meant to equal to y. But what was y equal to? Up here. Y was x cos x. So here I can actually rewrite the whole thing and say this is actually equal to x times cos of x. And that gives you a way to work with the equation where you can rearrange it to get what you want. So here we go, let's rearrange it. Remember integration properties, you can separate these two. So if you separate it, you can do cos of x dx separately minus x times sine of x dx separately, and it equals to x cos of x. This is called integration by recognition because you have to recognize that the one that you want is actually within your derivative. So here, this is what you want. You don't want the negative and you don't want that cos of x on this side, so move everything to this side of the equation. I minus antiderivative of cos of x dx, that cancels out. Then I minus this side by antiderivative of cos of x dx. And then notice there's a negative at the front here, so if I just times this by negative 1, times this by negative 1, times this by negative 1, this is what I get. Antiderivative of x times sine of x dx is equal to now negative x cos of x, and then that's plus antiderivative of cos of x dx. And then you're almost there. You're almost there. So this here, what's the antiderivative of x sine of x, which is what you're trying to find? I've already got part of the answer. This one I already know. I just need to figure out antiderivative of cos of x, which is we have. We've got a rule for that. Antiderivative of cos of x is equal to sine of x. So here, the answer should equal to x cos of x plus sine of x. That's what the antiderivative of x times sine of x delta x would equal to, given that I used part A. So I used part A to get to part B. That technique there is called integration by recognition. Okay, and you'll see that in the methods exam here and there. Usually exam 1, but they'll have to tell you part A, derive, part B, rearrange. It's usually a 3-mark question. So 1 for the first one, 2 for the second step. Okay, and sometimes they even get you to find the area between interval. Okay. I've got the next one just on the bottom for you to try as well. It's a similar skill, so I'm going to leave this as the main template. Have a go with the second one, then I'll write up the solution so you can see as well. Okay. But that's called integration by recognition. It's in 11H. There's only 1 or 2 questions from memory that's there. So if you want to practice them, you'll find just a few of them. But it's sometimes a bit tricky to get your head around at this step. Antiderivative of the derivative is just y. Okay, so this step here, antiderivative of the derivative is equal to y. Okay, that's a key property. And that marks the end of skill number 2 for chapter 11. Your last skill is your application. We'll go through it on Friday, and that concludes most of what you need to know for unit 3 and 4 so far. At least 3 areas of study.